microservices security in a different context. What's the specialty in microservice security? So that's what I'm going to explore in this talk. Yeah, so I authored 7 books. So these are the latest releases. Microservices Security in Action by Manning. That's the latest book. It will be released in April this year, but me petition is available, and probably end of this conference today, you will get a few copies of this. Okay, let's have a look at a monolithic application. Right. So if you take a monolithic application, let's say a web app, right? It can be a service or anything, but let's take a typical web app. A web application will expose its functionality to the rest of the world either through port 80 or port 9443, right? So you will have only very minimal set of entry points. So when a request comes to your microservice to one of those endpoints, it will hit an interceptor. If it is you are familiar with Java EE web applications, it can be a servlet filter or a Tomcat valve, right? Any sort of interceptor. So this interceptor will intercept the request, validate it, authenticate the message, authorize the message, make sure everything is fine, then only it will dispatch that request to other downstream components, right? And all these components, they run in the same process. So there are no remote connections between these components. All the codes are in-process codes, right? None of those components, once the request hits any of those components, they don't need to worry about the legitimacy of that message or the request. They don't need to authenticate again, right? So they can simply accept that request as a valid request. In case they want to know about who the user is, right? Probably you need to know what's the email address of this particular user or any other attributes of this particular user. If they want to do some particular login or do some authorization. In that case, they are centralized, right? Where all components in your monolithic application can access, and all those codes are just in-process codes. Right? So this is the security model here is much simplified. When it comes to microservice, now all those components, they would have their independent deployment, right? And there are many entry points. Instead of 1 or 2 entry points, now you have hundreds of entry points, or it can be even thousands, right? So that means we have a broader surface and we have a big problem to solve, right? So the strength of a system is no better than the strength of its weakest link, right? So we need to make sure all the entry points to our microservice deployment secured. Okay, and then again we also need to worry about how do we pass user context between these microservices. We need to do security screening at each and every entry point of all the microservices. So that's one of the key challenges. So let me list out some of the challenges, but then again, the challenges are not just limited to these 6, it can be many more. For the attack surface, that's what we discussed, right? So instead of protecting 2 entry points, now we need to worry about protecting hundreds, if not thousands of entry points. Then the performance. So when we have multiple entry points, right? When we are worrying about protecting all those entry points, so there will be security screening at each and every entry point. So whenever there's a security screening, when we want to do authentication at each and every end, so the latency to right in an effective manner at minimal latency into system. It's another thing that you need to worry about when you do a security design for your microservice deployment. Deployment complexities. Forget about microservices. If you have a 2-node cluster, right? 2-node cluster of a monolithic web application, even in that case, if you worry about how do you rotate certificates, how do you revoke certificate, that's still complex, right? Now think about a deployment with hundreds of nodes, right? It's a nightmare, right? To do all this management stuff. So unless you have right level of automation in place, you cannot do that. So that's why we think the Docker and microservices, they are a match made in heaven. They came at the right time, right? So unless we have containers and Kubernetes, microservices won't be mainstream today, right? They came, both of these concepts, they came at the right time. Then observability, right? So observability helps you to infer the internal state of the system looking at the external outputs. So we talk about logging, tracing, and metrics when it comes to observability. So in terms of security, a security audit can be a log, right? So it would say the order processing microservice accesses the delivery microservice on behalf of user Peter at this time of the day for this particular purpose. So that can be a security audit. Right? Then metrics is basically it's an aggregation of set of logs which will help you to understand the direction of the system. For example, average fail login attempts. That's a metrics, right? So if the average fail login attempts is abnormally high, what does that mean? It could be that your system is under attack, right? Someone is trying to get in your system. So you can configure alerts based on metrics. You can define thresholds, and based on that, you can define alerts. Then tracing, right? So this is the most challenging part in a microservices deployment. So tracing will help you to track your request from the point it enters into the microservices deployment till it leaves. So unlike in a monolithic application, in a microservices application, there are multiple services that would cater a single request. So that means you should know where your request is at any point in your microservices deployment. So you need to worry about having having tools for distributed tracing like Jaeger, Zipkin, those stuff. Okay? Then share in the user context. In the monolithic application, you need not to worry about sharing the user context. It's the session you manage in process, and all the components running in that process has direct access to the user context. But when it comes to microservices deployment, there should be a way to share the user context from one microservice to another microservice in a reliable manner, right? So we need to see how we can address that too. Then the polyglot architecture. The polyglot architecture helps you to have different teams to build microservices and pick whatever the programming language they want or whatever the technology stack they want, which are optimized to address their problem they are solving with their microservice. The challenge here is, in a centralized monolithic deployment, we have a centralized security team, right? So you probably, if you pick Java, so you'll be all the teams in your company would be using Java for development. Then we have a centralized security team who has expertise on Java, right? And would define how to do static code analysis, dynamic testing, and everything. But now with the polyglot architecture method, when you have different teams picking different technology stacks, you need to build security expertise along all those lines too. Every team should have a security expert. Right? So these are just few challenges you see when you move into a microservices deployment. Okay. So when it comes to microservices security, actually when you are writing the book Microservice Security in Action, we divided that into 4 areas. One is edge security, and then service-to-service security, deployment security, and then secure coding and automation. Right, so the book focuses on all those 4 areas, but in this talk I'll focus on first 2, edge security and service-to-service security. For a microservice, who would be the audience? Right? It can be a system which is accessing a microservice directly, right? Or it can be a system accessing a microservice on behalf of an end user or on behalf of another system, right? So this is the most common pattern we see to protect microservices at the edge. You use a gateway, an API gateway. You have all the microservices, the upstream microservices, and you can selectively pick a set of microservices that you want to expose outside your domain, right, and have an API for that. So if you have 3 microservices, you may expose just 2 microservices and define a set of APIs for them, right? So all the requests that you get will go through the gateway. So gateway will intercept all the requests and then validate the message. For security, we'll do authentication checks, we'll do authorization checks, and if everything looks good, then it will dispatch the request to the upstream microservices. So this is a common pattern we see. Okay. And yeah, so how many of you heard of OAuth? Okay, great. So this is why, the reason I mentioned before, right? So audience of a microservice is a system itself or a system on behalf of another system or a user, right? So that is why OAuth fits nicely into security microservice at the edge, right? So OAuth is an authorization framework for delegated access control. I won't go through the details here. Yeah. Okay. So OAuth is a de facto standard for securing APIs and securing microservices at the edge. Okay, this is how it happens, right? So you have a web app or any other system. It can be a mobile app, a system, or any kind of a client, right? The users first will log into this application, right? So to log into that application, you can use, this can be like, say it's a web app, right? It can be any federated protocol like OpenID Connect or SAML or any kind of a federated protocol. Then you'll be redirected to the identity provider, which is in blue there. Then users authenticate and come back to the IDP. When you get back to the web application, you will also get a token, right? That's in OAuth terminology, that's an access token. Then you pass that access token along with your API request, and API gateway will insert that request. Then API gateway will extract out the access token, the token that you pass, and call the issuer or the secret token service to validate this token. If all looks good, then it will dispatch the request to the upstream microservices. Now here, there can be an issue. If API gateway always tries to talk to the STS or the secret token service to validate the token, then there will be a performance issue, right? For every request, there's a remote call to validate token. To fix that issue, what we can do is, we can make the OAuth token a self-contained token, right? An OAuth access token can be a reference token or a self-contained token. If it is a reference token, we always have to go to the issuer to validate the token. If it's a self-contained token, then we don't need to. It's simply a JSON web token or a JWT, right? So JWT is a way of transporting set of claims or decisions from one place to another place in a cryptographically safe manner. So you can simply verify the JWT itself with the corresponding certificate, right? So in that case, the clients pass the access token, which is self-contained token JWT. So if the API gateway trusts the issuer, the gateway knows the public certificate of the issuer and simply can validate the signature of the JWT without doing a remote call, right? What's the issue here? The issue is in revocation, right? If it's a reference token, if you revoke it, then the revoke call will go to the secret token service, right? So when the gateway talks to the STS to validate the token, STS knows that this is a revoke token, right? So it will reject the validation request. But if it's JWT, since gateway never goes to STS to validate the token, gateway doesn't know whether it's revoked or not, right? So what do? We can have a short expiration time, let's say 2 minutes or 5 minutes. So you don't worry about the revocation, you just rely on expiration. So that's the best practice we see in microservices deployment. One example is Netflix, right? So Netflix uses mutual TLS to secure the communication between microservices, right? And they use short-lived certificates. Lifetime of certificate is just 4 minutes. So every 4 minutes they renew the certificates. But to get to that level, you need to have the right level of automation in place. Okay? Because revocation is not reliable, right? So if STS is down, right, what should you do? Right? Even with certificates, right? If you rely on CRL or OCSP, if the OCSP endpoint is down, what should you do? Right? So that's why, like, it's tricky to do check revocation of a certificate. So now the trend is you just rely on expiration, and based on how critical that particular business operation is, you need to define based on that the expiration time of your tokens. Okay, now let's focus on service to service security. Okay. One pattern, once again, now this has become an anti-pattern, right? Most of the people, as soon as they move into Microservices deployment, this is the pattern they pick because this is the easiest, right? You simply trust the network, right? So the request comes to the gateway. So gateway does all the authentication and authorization and dispatches the message to the upstream microservices. From there onwards, our microservices deployment, it trusts the network. So when one microservice talks to another microservice, there is no authentication, right? So that's a pattern we see, a preliminary pattern we see people use as soon as they move into microservices. But this is not recommended. And in this case, how do you pass user context, right? So gateway knows about the user, the end user, right? You may need to pass the user context to upstream microservices, right? Because each service can do authorization looking at the user context. Can Peter do a post to the order processing service? Can Peter do a gate to the delivery microservice, right? So authorization checks has to be local too, right? So the gateway will do coarse-grained access control, and each microservice will have its own fine-grained access control, right? To do fine-grained access control at the microservice layer, you need to pass the user context, right? In this model, you usually pass a user context as HTTP header. Once again, you trust the network because microservice foo can change the user context in a way it wants when it talks to foo microservice. That it cannot be cryptographically verified, right? Yeah. Now, slightly little improvement from the first model is you use mutual TLS, right? You don't blindly trust the network. When it comes to like service-to-service communication, you use mutual TLS, right? So that means if microservice foo has to talk to microservice bar, then microservice bar has to trust the certificate of microservice foo, right? But even in this case, the way you pass user context is through HTTP headers, which cannot be cryptographically verified. This model, so you have mutual TLS plus a shared JSON web token, right? So when the STS validates our access token, which comes from the end user, after validation, it will produce a JSON web token. That JSON web token may include who the client is, who the user is, and other parameters, like if it is auth, some set of scopes, audience, those stuff, right? And that JWT is signed by the issuer, the STS. And now the gateway, along with the request, you pass the JWT to downstream microservices. Okay? And then still you have MTLS for authentication between microservices, and then you pass JWT between microservices to carry the user context. And in this case, you cannot modify the JWT or change the users, the context of the user, because a JWT can be cryptographically verified. Okay? That pattern, the previous pattern, it has some issue, right? So when you get a JWT has something called audience, right? So if I want to access order processing microservice, then the audience value, the JWT should carry an identifier that points to the order processing microservice. Right? And if I want to access the delivery microservice, then JWT should have an audience value that points to the delivery microservice. But in this case, we have a shared JWT. So it will have a common audience. Right? So it has some issues too. Because a JWT can carry a set of scopes. Scopes defines what the actions a particular microservice can do with that particular JWT. Right? To fix that, what you do is you pass a JWT from the gateway to the microservice, the first microservice, right? Then when it wants to talk to the second microservice, it has to exchange the initial JWT it got from the gateway to a new JWT. And new JWT will carry the audience of the second microservice. Right? So if you look at OAuth, so there's a RFC called OAuth token exchange. It became an RFC we called 2 before. Right? It defines to do this token exchange in a standard manner. Yeah. Then again, when you implement this stuff, right? You won't try to implement all the security or build all this security validation into a microservice itself. It will in fact violate the microservice principles. A given microservice should only focus on one aspect, the business problem. Right? To fix that, what we do is we build all the security validation into a proxy. And we deploy this proxy along with your microservice. All the requests coming to your microservice will first hit the proxy. Then proxy will do the MTLS validation, mutual TLS validation, JWT validation. If it has to do token exchange, proxy will do that. So the security experts in your company will develop this proxy. Right? So other developers, they don't need to worry about that. If there are any issue in the security proxy, then you just need to redeploy the proxy. You don't need to do any changes to your application, right? Microservice. Yeah. Okay. So this is what we call the data plane, right? Data plane is the one which handles all the runtime traffic, user traffic, right? So the first request comes to the gateway, then gateway will dispatch it to a microservice, then you have a proxy. So no request can come to a microservice without going to the proxy. Right? So with the network rules, with IP tables, you make it happen. Right? So all the requests will go to this proxy, and proxy and the microservice will be in the same machine. Right? And the communication between proxy and microservice, they are local calls. They never cross the machine boundaries. Right? Yeah, so this is a data plane. Then you have control plane, which defines the control instructions. Right? For example, like you may define like rules to validate a JWT. Who are the issuers you trust? To validate MTLS connection. Who are the issuers or the certificate authorities you trust? Right? So those are defined in the control plane. And if you want to provision certificates, so how to provision those certificates are once again defined in the control plane. So control plane handles all the control instructions, and those will be dispatched to the microservices. Okay. So let's take an authorization example, right? So you have a proxy and you get a request with a JWT. JWT carries the user context. Then the proxy will intercept the request and validate the JWT, extract out certain parameters from the JWT, the service, the system, and the user, and other attributes. And then it will create an authorization request, and it will talk to some policy decision point, authorization endpoint running in the control plane to authorize a request. Right? So this method is called call home method. Right? So if you are familiar with Istio, so Istio is using a similar model for authorization. So the other model is the embedded PDP model. You don't talk to the control plane to validate it, but you have an embedded policy decision point which is deployed along with your microservice. So always the communication between proxy and PDP is a local call. So in terms of performance, it's a much better approach. But then again, you have challenges, right? So if the policies get changed, so there should be a way to update all the PDPs. So you need to worry about those stuffs too. Probably you will use some eventing mechanism, right? Which will send an event whenever a policy gets updated. Then probably you will update the runtime by getting the latest policies, or else you would simply reboot that particular microservice. Yeah. So when it comes to authorization, you can have your own way of defining authorization policies, but we see Open Policy Agent is one of very popular project in the Microservices domain. It has introduced its own programming language called Rego, right? In Rego, you can define your access control policies, and then you can deploy OPA as a centralized server, and it exposes a RESTful API. Then from your microservice, you can talk RESTful API and see whether your request is authorized or not. That's a very high-level picture, but you can have it in any way you want, right? So in this case, you can have proxy which intercept the request, then talk to your authorization, the PDP at the control plane, then PDP can talk to the OPA server via its REST API. Or else you can embed the OPA policy agent into your Microservice deployment itself without doing a remote call, right? So you have multiple deployment patterns. Yeah. So far what we discussed leads us into this service mesh. Right? So service mesh is an architectural pattern which helps us bring in the best practices around security, observability, resiliency, routing control to our microservice deployment. Right? So it has a control plane and it has a data plane. So in control plane you define security controls, routing rules, and whatever the policies you need for resiliency and observability, those stuff you define at the control plane, and then the data flows to, the runtime data flows to the data plane. So this is an architectural pattern, and we see multiple implementations. The most popular one is Istio, and then there's another one called Linkerd. So let's have a look at the Istio architecture at high level. So Istio has, in the control plane, it has three main components: Pilot, Citadel, and Mixer. So Pilot is the component which defines routing controls and then configurations for your microservice deployment. For example, it can define a policy saying, when order processing microservice talks to the delivery microservice, send 80% of the traffic to the version 1 of the delivery microservice and send 20% to the version 2 of the delivery microservice. So you can define those routing rules in Pilot. Then Citadel handles certificate key management. So whenever your microservice boots up, you can configure to provision certificates and also rotate certificates. So those things can be defined with Citadel. Then Mixer, it has a plugin architecture. You can create your own plugin. So when it comes to OPA has a Mixer plugin for authorization, right? And also if you look at the data plane, so there's a proxy in Istio architecture. So that's the Envoy proxy, right? So when a request hits the data plane, the proxy will capture the request and it will talk to the Mixer, right? Then the OPA authorization plugin running the Mixer will pick the request and do the authorization based on the policies that you define, right? So you can define your own plugins as well. Then monitoring, login plugins, everything can go under Mixer, right? So proxy, the Envoy proxy will handle MTLS connections and then also do JWT verification, right? So one challenge we discussed before is certificate management. How you revoke certificates and how you bootstrap trust, right? That's a challenge in the Microservice deployment. So we have Spiffy, another open standard. It has an implementation called Spire, reference implementation called Spire, which helps to bootstrap trust between microservices in a platform agnostic manner. Right. So I may not go through the details. So basically what happens is, in Kubernetes terminology we have pod, right? So all your microservices running in a pod, in a container, right? So then all the pods, right? All the pods running in a Kubernetes node, right? So in specific architecture, you have a node agent which is running in the Kubernetes node, right? So whenever the node agent gets up, it will talk to a specific server or a Spire server, and it will ask for all the workloads or microservices it can host in that particular node, right? Then Spiffy will define an identifier for each node. This is at a very high level, right? I think you need to go through the spec and read through it. And then whenever your pod comes up, right, each pod, a container there, has a workload agent. That workload agent will talk to the node agent to get its own identity, right? So then looking at like the parameters around the request, the node agent will validate that, and if a legitimate node to schedule on that particular node agent will share the corresponding identifier with the microservice or the workload. Right? So it has a concept called Spiffy ID, and Spiffy ID can be embedded into a JWT or a certificate. So this is a very high level overview. If you have any questions, like we can discuss over lunch or any time of the day. Yeah. So then this leads us into the zero trust network pattern. So we started with trust the network pattern, and I mentioned it's an anti-pattern. Then today what we call as a best practice is the zero trust network pattern. So with the zero trust network pattern, we don't trust the network. We accept that network is hostile. So if network is hostile, what should we do? How do we secure our services? The bottom line is, if the network is untrusted, if you don't trust the network, then we should do security screening as much as closer to our resource or the microservice. So we don't trust network, anyone. Whenever request comes, I'll validate it myself, right? So that's the basic principle. So that's why this service mesh architecture helps us do that, right? You don't trust any request, the proxy which sits alongside with your microservice will do the security screening and validate it, right? So to implement security trust principles, you can use a service mesh. Okay. Yeah. So these are some of the zero trust network practices. So you keep security enforcement points as much as closer to your resource or the microservice. Then you should avoid using bearer tokens, right? So if you are familiar with OAuth tokens are bearer tokens. So bearer tokens are like cash, right? So if I steal $10 from you, I can use it at any Starbucks. No one will question like how I got that $10, right? $10. So the opposite of bearer tokens is proof of possession tokens. That means before using the token, you need to prove that you possess that token. A credit card is like a proof of possession token. Like if I steal your credit card, whenever I try to use it at Starbucks, I need to sign. Okay? So basically you need to prove the possession before you use that. So you need to use some kind of a proof of possession token. The way to convert your OAuth tokens to OAuth bearer tokens into a proof of possession token is to use it along with MTLS. Right? And there's another spec, there's another RFC called OAuth token binding. So that also helps you to bind your OAuth tokens underneath transport channel. Yes, and then do contextual access control and make access control decisions near real time. So that's why this call home pattern and embedded PDB pattern differ from each other, right? So if it is embedded PDB pattern, you may have some policies, right? In case you don't get policy updates, then you are validating your request against some stale policies. Right, so you need to think about all this stuff. Then automation is a key, and also you need to worry about distributed tracing and monitoring. Yeah, Yeah, so this is the end-to-end flow. Right, let me quickly walk you through that. So you have the application, web application. So users, they want to access this web application. Then they will get redirected to the identity provider. It can be SAML, OpenID Connect. Then you get back with a token. Then the system or the application will use that token to access an API, and to make it a proof of possession token, you will use MTLS along with the token. So MTLS will make sure only the legitimate clients can access the API gateway. Then the API gateway will talk to the STS to validate that token. But if it is self-contained token, you don't need to do that. You can validate by yourself. And if the token is valid, then the STS will issue a JWT, JSON Web Token, which carries the user context. And once it will be signed by the STS itself, then you pass that JWT with a request to the microservice. That connection is also protected with MTLS. That will make sure only the gateway can access the first microservice. Then proxy will intercept that request, validate the JWT, validate the MTLS, carry out all the authorization checks against the JWT, and will dispatch the request to the upstream microservice. The connection between proxy and the microservice, that can be insecure. You don't need to worry about security here because it's running in the same machine. It's not a remote connection, it's a local connection. Then after that, if first microservice wants to talk to another microservice, once again that request will go to its own proxy first. Then based on the policy, it will enforce MTLS. Then it goes to second proxy will carry out the same checks. Right? Then again, the communication between microservices, it can be HTTP, or it can be gRPC, or it can be like reactive microservice using Kafka or any kind of an event broker. So based on the transport you pick, you need to decide how you can transport these headers. Right? If it is HTTP, you can pass headers. Even with gRPC, you can do that. You can use MTLS, and also you can pass JWT in gRPC using metadata. You can do the same with Kafka too. You can use multiple options there with Kafka. You can use MTLS, you can use SSL, and if you want to pass OAuth tokens, you can use SSL OAuth bearer. So there are multiple options. So based on the transport you pick, you decide how you can pass these headers. Yeah, so that concludes the talk. Any questions? Yeah, first question is it okay to use